Okay, welcome back to the Mentored Engineer. In this video, we are going to look at our vertical section of our jib right here, where the jib attaches to, and then eventually down here, that's where the log splitter attaches to. You see here, I've drawn it at an angle to simulate operation on a slope. Now here it's drawn at about a 30-degree angle, but we're probably only going to use it on about a 5-degree angle. Honestly, I think I would be scared to use it on more than a 5-degree angle. Alright, so what we're going to look at is our bending and our torsion, and there's a little bit of axial load we'll throw in there as well. Alright, so we got some equations. Let's look at our bending moment first, because I think that's the biggest one. We're going to sum that here at B. So when calculating our moment, we're going to use our load. We got a length L, the sine of the height here, and this little offset here, D1, and that's going to be multiplied by the cosine. So let's put that here. We got W times L plus the height times sine of theta, which is 5 degrees. So we'll put theta equals 5 degrees. All right, plus D1 times the cosine of theta. Now, if you look at the cosine of 5 degrees, it is 0.996, which is essentially 1. So we're just going to say that term goes to 1, and we just keep our D1. All right. Now, the next thing we're going to want to look at is the torque. And you probably think that the torque is, I just push here and whatever it takes, that's the torque there. And that would be true if it was welded, but it is not. All right, so we're going to have to make some assumptions. The first thing we're going to assume is our coefficient of friction. And our coefficient of friction is going to be something high. I mean, so steel on steel is generally about a 0.3. If we oil the steel, it can go down to, I think, as low as 0.1. Obviously, we don't do that. We're not going to want to oil it. We probably don't want a coefficient of friction that low, just because we don't want this thing moving around wherever we want it. Move it, and it stays. All right, so in my mind, this thing is going to get rusty and pitted, and the surfaces are going to grind together like pieces of sandpaper. So I'm going to go higher. I'm going to say that our coefficient of friction is going to be about 0.5. All right. I think that's a good assumption, and we can obviously check that when we actually run the numbers and get into MathCAD. All right, so we're going to take a little deeper dive in here. We're going to take a section right in here. So let's look at here. So we're going to make our ID of the tube. Draw our OD, and we've got the blue plate that is the pivoting part. That's this part right here, and it's going to go out here. All right, now when the jib's just holding its load there, it's got a force pulling on it right there. All right, and that's going to be our F sub T, and we'll use that in a second. All right, so what happens is we pull it, and we essentially make contact there. All right, and for all intents and purposes, we could put a little spot of weld right there, and it would work. And then we're gonna go ahead and push it. So we don't care what the force is, but what's going to happen is it's going to push, and it's going to push this way. If it's welded right there, it's going to pivot up, and it's going to make contact right here. Now, interestingly enough, these spots will always be perpendicular. All right, and they'll go to the quadrants if you're using orthogonals like this. Okay, so what happens is our torque is going to equal the coefficient of friction, because that's where we're going to try to get the slide on those points. All right, and it's going to get multiplied by F sub T, and then half the diameter, which in this case is the OD divided by 2. And since we've got 2 of these, and they're going to have the same load as we'll calculate in a second, we're going to need to add two of them in there. So that's going to be our equation for torque. So let's look at this Ft so far and get what that's going on there. All right, so that's simply going to be our weight. All right, and we're going to take this as a moment right here and then divide it into a couple. All right, so length times, force times length, and we're going to add in this little offset of D1 as well. All right, and all it's going to be divided by D3. Well, that's all for this episode of The Mentored Engineer. Thank you for watching, and look forward to our next video as we put this in a MathCAD, and we'll actually calculate the stress at the base point. And I hope you are able to apply this in some other application. Just think about things a little bit differently than you have and grow. Thank you for watching. Have a great day.